All right, so today's lesson is 2.4, energy and chemical reactions. And so we talked about chemical reactions quite a bit in the last few lessons. We've looked at what is some evidence of a chemical reaction. So we talked about things like there's heat given off, or there might be heat released. There might be some changes in odor. Maybe there's a color change. Maybe there's a gas given off, or you might see some bubbles. And also, most importantly, is that when there's a chemical reaction, there's something new being produced. And this new product has its own new properties. So an energy change here, it is an obvious or sometimes obvious, it can be unnoticeable production or absorption of a form of energy. So for example, sound, light, and heat, and it's part of a chemical change. So for example, fireworks. It's an example of an obvious energy change. Fireworks explode. We can see that there's a huge amount of heat and light given off. Something that may be unnoticeable with heat, with the example for heat is rusting. So rusting is an example of a chemical reaction, but it's an unnoticeable energy change because there's still heat being released when metal rusts, but the amount is so small that it actually takes very sensitive equipment to detect it. But in both cases here, energy here, heat was being released. So knowledge of energy and energy changes is important to society and industry. For example, gasoline in automobiles. Gasoline is burned in an automobile engine, and when this happens, when the gasoline is burned, that chemical reaction results in the motion of the car, but there is also production of heat. So we need to know how much heat is being produced so that specific equipment can be designed, such as a radiator, to cool down the engine. And this way, the heat produced by the chemical reaction does not damage the engine. So when we talk about reactions, there's some specific names given to reactions. So today we're looking at an exothermic reaction. Last class we had talked about a combustion reaction and a neutralization reaction. So here we're looking at an exothermic reaction first. So an exothermic reaction is any chemical reaction that releases heat. Heat is also called thermal energy. So for example, gasoline working an engine because it releases energy into its surroundings. Another example, metabolism, the breakdown of food, the breakdown of the nutrients like fats and carbohydrates in the human body, that also releases heat. And then that other obvious example of fireworks, that would also be an exothermic reaction because there's a release of heat. Then there are endothermic reactions, and these are chemical reactions that absorb heat. So again, heat is thermal energy. An example of endothermic would be photosynthesis. The solar energy from the sun is being absorbed by the plants. So plants absorb the energy in the form of heat or light, and they need that energy from the sun to produce glucose, which is their food, and they also release oxygen from the carbon dioxide and water. So some other examples of exothermic reactions and endothermic reactions. So the formation of snow is an exothermic reaction. Burning, any type of burning is an exothermic reaction. So burning a candle, burning wood, a gas burner in use here, those are all exothermic. Endothermic, absorb energy. So an instant cold pack, it actually absorbs energy and then becomes cooler. For use on injuries or sprains. Cooking. Anytime we're cooking or baking, Those are endothermic reactions because they're absorbing energy. And then photosynthesis is another example that we already talked about. All right, we do have a short video to watch, and then there are some questions to do. So because we are done all of chapter 2, so you'll work on the chapter 2 review questions as well as numbers 1 to 3 for 2.4. And I'm just going to play this video.